What's the integral for the average momentum of the particle? Okay, if you want the average momentum, expectation value of p sub x, what's the formula? It's going to be direct bracket notation, psi px hat psi, right? And what will that give you? Integral of psi star. What's the momentum operator? Kayla, you remember the momentum operator? Catherine? Hyder?
It's
H bar over I d by dx, derivative with respect to x of psi dx. Okay? And we're going to integrate this from what to what? 0 to L. Okay? Because this function, well, we really should be doing it from negative infinity to infinity over all possible x's, but you know that psi is going to be 0 beyond your box, so we'll just constrain ourselves to 0 to L. And so you just plug in your expression for psi. You're asked for n equals 3. Okay? And what do you think this is going to come out to be? Let's go back to our expression. Sine 3 pi x over L, right? Let's write this using Euler formula. And going back to the Euler form, the exponential form, this is, what was it? 1 over 2i. I think it's 1 over 2i e to the I at kx, which k is n pi over L, right? So 3 pi x over L minus, remember, e to the negative I 3 pi x over L. What do you remember from our free particle lesson? This is an eigenfunction of the momentum operator, right? What's the momentum for this one? H bar k. And what's the momentum for this one? Negative h bar k. So there are two possible values of momentum you'll get. If you were to measure the momentum of this particle, it's not going to be well defined, right? It can either come out h bar k or negative h bar k. What's the probability it's going to be h bar k? Look at your coefficients. The coefficients for these two eigenfunctions of the momentum operator are the same. So it's 50-50. 50% chance it's going to be moving one way, 50% chance it's going to be moving the other way. What do you think the average momentum is going to be? Equal chance it's positive or negative. What's the average? 0. Average momentum is going to be 0. And you can show that with your integral. So let's do the integral. Average momentum, integral of, what was it? Square root of 2 over L sine, what's our n here? 3. I'm just going to put n here. Okay. N pi x over L times h bar over I. Derivative with respect to x of n pi x over L is what? What's the derivative of sine? It's going to be cosine n pi x over L and times what? Times n pi over L. Keeping in mind that n pi over L is really k, right? So what do we have here now? I can factor out h bar over I, and this is integral from 0 to L. And I can factor out, oops, I forgot the square root of 2 over L here, huh? This one, that should be down there. So I can factor out 2 over L. And I can factor out n pi over L. And what do I have left inside? Sine kx cosine kx dx from 0 to L. Okay. Remember, k is n pi over L. So what does that give me? Do you think this is going to come out 0? That should come out 0 if you integrate that.